Hi, I'm Chris Schomburg, and today we're going to learn a little bit about electronics, and specifically AC-DC power. Now we're going to start with DC power, but this actual trainer has AC and DC power to it. So that's actually a really cool thing. It's actually made by Armatrol, and it is an Armatrol test station, and it is actually for this class. And later in this class, you'll actually do a practicum where I will give you a 2-hour window where you'll sign in and meet with me one-on-one to go through this station or a station much like it. And you'll actually hook up and wire all the wires. It'll either be for your midterm or for your final. So it'll be a practical. Okay, so really what I'm trying to teach you here is the basics of DC and AC power. Now, in your labs, you've actually worked with DC power and 9-volt batteries using a breadboard. Now that, you learn a couple things that are really important that we're going to learn about today. The first thing is how to actually measure something. The second is actually how to get LED to light. In this case, we're going to try to light an incandescent bulb. This is a meter. Now this is an old meter. It actually uses induction to actually move the needle. So there's a coil, and that coil has current coming through it, and then it actually turns a needle. It's called a galvanometer. And the needle actually turns, and initially these galvanometers turn the needle through induction to see how high a current or voltage was actually applied. So it could actually read current or voltage. It was the first voltmeters or amp meters were designed this way. And in the 1960s to about the 1970s, they used these. In the 1980s and 90s and 2000s and later, we used digital signals. And those actually use a digital output to go ahead and output how high a current is. It uses an 8-segment display, and we'll learn about that. Okay, so today, what we're going to do, we're actually powering this whole thing with, this is actually a DC battery. This is supplied by solar, so I'm actually getting this from up top of my roof. I supplied it, and I had it 100% before. I've done a little testing, so we've lost about 1% in the testing that I've done so far. But basically, we're going to power this whole station by generation from solar. So real quickly, we're going to turn it on. Okay, you can see that it actually has a green light. It takes DC power, which is a battery, and uses a lithium-ion battery, which is one of the new up-and-coming batteries that's actually used in by Elon Musk. And then it creates a inverter. It actually uses an inverter and inverts this to AC. So this is an AC plug. It goes down to the trainer. This AC plug-in is actually a 115 to 120, and this is typically 120 volt VAC, and we'll learn about that once we get into the AC signals. And then it could be either 50 cycles or 60 cycles. Now, in Europe, they use 50 cycles, and there's other countries that do too. In the US, we use 60 cycles hertz. And then the fuse is 4 amps. So we know that it can't get over 4 amps, otherwise that fuse will break. And so then we have a time delay on this too. So this is actually where we can power the whole station up by flipping the switch. Okay, so that is the power flip. Now you can actually hear it turn on. We can't see anything yet, but what we can do is we can turn this AC circuit breaker. So we went from 4 amps maximum to 2 amps maximum. And so then now we can see there's power here. All we can tell is that the light is on, so hopefully that means that the power is there. Now we can switch this to DC, and now we actually know that we have DC power here. I'm going to go through a couple of these things really quickly. So the first one is this is 12 volts, negative 12 volts to ground, and then positive 12 volts. If you go from here and here, that's actually 24 volts. So here and here is negative 12 volts, here and here is positive 12 volts, here and here is 24 volts. Now, this is the old time galvanometer voltmeter, and it actually moves the needle with the induction in the coil. So that's actually how this works. We're gonna power that up. Later, we're gonna actually power up a light bulb, and then all 3 light bulbs in series. And then hopefully we'll actually use a resistor to do that to start out with, just because it's safer to do that, and that's what our lab suggests for us to do. Okay, so to do this, we're going to go ahead, we're going to grab all of our probes, And these are actually test probes. They're kind of expensive. They're called banana to banana clips, and that's actually what works in here. So one thing you want to make sure when you do this is when you pull on the plastic instead of on the wire, because that could pull the plug out. And if that happens, you know they're going to have an intermittent failure, which is not a good failure. You don't want an open circuit failure. Okay, so let's go ahead. We have the power on. We're going to go ahead and turn it off and think about our strategy, what we're going to do first. Okay. So strategy-wise, we want to go ahead and power up 12 volts DC. Okay, we're just going to start with the DC volts. We're not going to talk about AC today. That'll be for after the midterm. So first of all, what we're going to do is we're going to hook up the 12 volts. This is the power to the red. So red to red. And then we're going to go ahead and we're going to go black to black. Okay? So let's just make sure that that actually makes sense. If we take this and we put this up like this, we can see that's basically a loop. The negative rail is right here, so we start with the negative rail, the ground, and the electron flow goes from negative. It's going to oppose on same charges oppose each other. So if we have a negative and we have a negative electron, it's going to try to repel and go away from this. It's going to go through here, go through the meter, go through the positive end, and into the 12 volts. So that's a circular loop. We should see that. Okay. Now, let's go ahead and power everything up. So we're powering the solar that came from my solar up on my roof, okay, into the battery, to the 120 volts. Turn on the main. Turn on the 12 amps or the 2 amps. We're good there. We're going to then measure it. Now, at this point, we're actually seeing a little bit over 12 volts. We're seeing 13 to 14 volts. It's not quite 15, but it's a little bit higher than what we initially thought. We'll actually take another meter, a multimeter, and test that later. But for now, we're just going to take it using the galvanometer style meter, which is an old voltmeter. We'll use that. But in the future, we'll use a digital multimeter to test that. Okay, so we're going to turn all this off. Okay, so the next thing we want to do is we want to test the 24 volts. Make sure it's actually working properly. So what we're going to do is we're just going to change the ground. So this ground pin is going to then go to the 12 volts. So we have negative 12 volts, or negative 12 plus 12 is 24. So that's the total voltage there. Now this is a common ground. So essentially what we're doing is we're taking, this is the ground rail, and this is the high rail. And so instead of being 12, it's now 24 volts. And you can see that red right here. Okay? So this should be the proper setup. So let's go ahead and let's power it up to test our theory. Let's power the main power. Let's power the AC. We see that. And we're going to go to the DC voltage. Now, we actually saw a change in the meter. Before, it was somewhere around here. It was around 12 volts. But now we're actually seeing it above 25 volts. So it's almost about, it's actually 27 volts. So it's actually very high, a lot higher than we normally would think. But that's something that we have to take care of and really know that that's actually what's happening. We'll measure this in another lab. Okay, I turned everything off. Okay, so the next procedure, I'm going to pull this off here. Again, I'm pulling with the plastic instead of with the wire because you don't want to pull those plugs off. And I'm going to put those plugs down. Okay, proper cleaning procedures. You should always try to put all of the blacks together. So we should have all of the black rails together, and we should have all of the red rails together. And what I always do is I always hook them on the end here. Okay? Why I always do that is because then I always know where they are at, and I can always access them later. Okay. So we've cleaned up. We've went ahead and we've learned a little bit about power. We've learned about AC. We've learned about DC. We've learned that this station can actually supply 12 volts and 24 volts. It can actually supply a negative 12 volts and a positive 12 volts if need be. And that's something that we'll look into next time with the buzzer circuit and the fan. We'll also learn about a potentiometer, or a rheostat is what it's called here. And we'll go into a solenoid in the future too. Well, I hope you learned a little bit about this electronics today with the Amatrol station.